Hi to all of my awesome students, which means you. We are going to do the last video for this chapter, and it's the formulas using for regular polygons. And so we'll talk about what a regular polygon is as we go throughout the notes. But just as a reminder, the sum of all interior angles for any polygon, so any n-gon, is the number of sides, so n, minus 2 times 180. Okay. For the sum of all exterior angles, no matter what, it's 360 degrees. And then to find the diagonals, it's n times n minus 3 divided by 2. And that's just a recap of what we've been doing. Okay, so what is exactly a regular polygon? A regular polygon is a polygon that is both equilateral and equiangular. Okay, so basically that means that all the sides are congruent and all the angles are congruent. So we've actually been working with two regular polygons that you didn't even know. One is an equilateral triangle. So an equilateral triangle has all sides congruent and all angles congruent. And then a square, we've worked with that one already. All angles congruent, all sides congruent. This is what a regular pentagon looks like, and this is what a regular hexagon looks like. And we could keep going on. We could do a regular heptagon, a regular octagon, and we can keep going on and on and on. But just know that a regular polygon, all sides are congruent, all angles are congruent. Okay, so the measure of each interior angle, so that means the measure of each individual angle of a regular polygon has a special formula. So remember, to find the sum of any polygon's interior angles is n minus 2 times 180. But now if I wanted to find the one, okay, so this is another way you can think of this as one interior angle, I have a little formula I can use. It is n minus 2, so interior angle is equal to n minus 2 times 180, so that's the same, but then we divide it by the number of sides. Think about why that's true. If it's a regular polygon, that means all the angles are congruent and all the sides are congruent. So if you have the total measure of degrees and you divide that by the number of sides, that's going to give you your angle. So a perfect example that we've already been working with is a square. A square has 360 degrees. It has 4 sides. Each angle is 90 degrees. Well, don't we know it has an angle of 90 degrees? Okay, so it says determine the measure of each interior angle in the regular polygon below. So first we need to figure out the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. Okay, I always like to mark it instead of just trying to count in my head so that I don't miss a side or don't count a side twice. So for an interior angle, we're going to take 9 minus 2 times that by 180 and divide by the number of sides, which is 9. So 1260 over 9, and that gives you 140 degrees. So that means each one of these angles, let's actually mark it, each one of these angles is 140 degrees. Okay? And they're all congruent, so that's why they all only have one arc. Okay? Okay, so then we might have to work backwards. So it says each interior angle of a regular polygon is 135 degrees. Determine the name of the polygon. So we have to work backwards in this example. So we're going to set the interior angle to 135. We're going to do n minus 2 times 180 divided by n. So since I have an n in the denominator and an n in the numerator, I need to get rid of that n. So I'm going to multiply both sides by n. This side's going to cancel out. So I have 135n equals n minus 2 times 180. Okay. And now this looks much better. This looks much more like a linear equation for us. So 135n equals 180n minus 360. Okay. Remember, with a linear equation, you want variables on one side, numbers on the other side. So I'm going to go ahead and subtract 180n. Okay. That gives me a negative 45n equals a negative 360. Divide by negative 45, and n equals 8. Now, before we classify what type of polygon this is, a regular polygon, remember that n should always be positive. So if you do your math and you don't get n to be positive, you made a mistake somewhere. And why does n always need to be positive? Because n represents the number of sides. And you can't have a negative number of sides. So the name of this polygon is a regular octagon. And the reason why it's regular is because all interior angles are the same, which means it's also going to be equilateral. Okay, so what about an exterior angle? Well, remember that the sum of all exterior angles, no matter the shape, the number of sides, etc., is 360 degrees. So for an exterior angle, for a regular polygon, we just take 360 and divide it by the number of sides. So it says determine the measure of each exterior angle of a 22-agon. So 22 is the number of sides, that equals n. It's an exterior angle, so that means we have to work with 360 degrees. And we divide that by the number of sides. So that gives me 16.36 degrees. Okay. Let's actually go up and do this for this problem as well. So if I wanted to do an exterior angle, okay, I take 360 degrees, I divide it by 9, so that means each exterior angle is 40 degrees. Okay. And if they were to give you the reverse of this problem, you would do, let's say 40 equals 360 over n, multiply both sides by n, so 40n equals 360, you get n to equal 9. All right, let's go to the last page of the notes. Square. And I actually just kind of helped you for the next problem. It says the measure of each exterior angle of a regular n-gon is 18 degrees. So focus on the exterior, so that's going to be 360. So we have 360 divided by n equals 18. Multiply both sides by n. This side just cancels out. So we have 360 equals 18n. So n equals 20, and that's a 20-gon, a regular 20-gon. And we can just say it like that. Remember, the ones under 10 are the ones that you should definitely know. If you want this special name for one, this is the, I don't even know if I'm saying this right, icosagon? Sure, great. I like regular 20-gon much better. Alrighty, last two questions and we are done with the video. Okay, determine if each statement is true, always, sometimes, or never. If a polygon is equilateral, then it is equiangular. So one way I like to do these problems is to think back to parallelograms, because we have a square that's a parallelogram, and a square is a regular polygon, okay? And we know all the properties of our parallelograms, or at least hopefully we do. So if a polygon is equilateral, then it is equiangular. So let's think about our two quadrilaterals that are equilateral. One's a rhombus, one's a square. Are both of these, or neither one, or just one of them, equiangular? Well, a square is, a rhombus is not. So this is sometimes. Okay. And then I'll do the same thing with example B. If a polygon is equiangular, then it is equilateral. Well, let's go back to our quadrilaterals. We have two equiangular parallelograms. One is a rectangle, and one is a square. Now, a square is also equilateral, but a rectangle is not. So again, this is sometimes. Okay, so even if it uses the word polygon, I would revert back to our quadrilateral properties because we should know those and just apply it that way. Okay, awesome, you rock. Thank you so much for tuning in for a lesson with Mrs. Harding.